right. Our first unit of study in AP Human Geography is going to be called Thinking Geographically. And it's really going to lay the foundation for the rest of the course. Everything that we talk about in Unit 1, we're going to come back to again and again and again in the next 7 units. So you really need to grab hold of everything that you're going to be getting this unit, because you're going to need to understand these concepts in order to be able to apply them in when we talk about population or when we talk about urbanization. If you don't understand these concepts, when we get to those, you're going to be completely lost. So the first part of Unit 1 is an introduction to maps. So at the end of Topic 1, you should be able to identify the different types of maps, identify the types of information presented in maps, and different kinds of spatial patterns and relationships portrayed in maps. So when we're done with this topic, you should be able to do those things. Oh, bell. So the thing about maps is there's no better way to represent and identify spatial patterns on the Earth than maps. They're essential to our everyday life, and presenting information, there's no better way to do it than on maps. But the thing about maps is they're all wrong. Maps are inevitably distorted. What that means is no matter what, when you look at a map, it's wrong in some way, shape, or form. They're inevitably distorted in shape, area, distance, and direction. Okay? One of those things is always off when you're looking at a map. So why? Why do you think looking at a map is inevitably distorted? Inevitably is the important word here because that means there's no other option. You're looking at a map, it is wrong. So just think for a second why it might be wrong. I'm not going to make you sit here awkwardly too long, but just think, why would me looking at why would it be wrong? Why would it be messed up? It looks fine. It looks like the world. Why would it be messed up? Well, the answer is because the Earth is a sphere. Let me try to get this out of the way. And maps are flat. And, when I first heard this idea, I was like, but would it make that big of a difference? Like, you literally just kind of have to unfold it. That's true. But I'm about to show you a picture that you're never going to be able to unsee. This is an unwrapped head. Okay? I know it's weird, but this was what, if you took someone's head and unwrapped it, this is what it would look like. Okay, you took this spherical object and you flattened it. It's inevitably messed up because that's not really how it's presented in real life. But in order to flatten it, you have to kind of unwrap it, and so the direction or the space between the eyes and the ears seems so far, so that's distorted. The size isn't distorted, but the space is. So that part is distorted. And I want us to watch this video because he does a really good job of explaining, why maps are so distorted.
All right, here we go. If I want to turn this globe into a flat map, I'm going to have to cut it open. In order to get this globe to look anything close to a rectangle lying flat, I've had to cut it in several places. I've had to stretch it so that the countries are starting to look all wonky. And even still, it's almost impossible to get it to lay flat. And that right there is the eternal dilemma of map makers. The surface of a sphere cannot be represented as a plane without some form of distortion. That was mathematically proved by this guy a long time ago. Since around the 1500s, mathematicians have set about creating algorithms that would translate the globe into something flat. And to do this, they use a process called projection. Popular rectangular maps use a cylindrical projection. Imagine putting a theoretical cylinder over the globe and projecting each of the points of the sphere onto the cylinder surface. Unroll the cylinder and you have a flat rectangular map. But you could also project the globe onto other objects, and the math used by map makers to project the globe will affect the way the map looks once it's all flattened out. And here's the big problem. Every one of these projections comes with trade-offs in shape, distance, direction, and land area. Certain map projections can either be misleading or very helpful depending on what you're using them for.
All right, so you saw there how he said that in order to kind of take the globe and turn it into a usable map, map makers project the globe onto different surfaces. So one might be a cylinder, there's like a conic shape that some map makers use. But what that turns into is the different types of map projections. And so a map projection is the process of a cartographer or a map maker showing the curved surface of the Earth on a flat map. And one thing that you do need to remember is that map projections are always off. You can say that they're sad because in some way the shape, the area, the distance, or the direction is messed up. So we call map projections sad. And that's one way you can remember that. Since maps are selective in what they portray accurately, different projections have different purposes and are used for different things. So we're about to look at some of those map projections and look at how they're good and how they're not so good. So what they can be used for. The first one is a Mercator projection. And this is a pretty popular one. And it's used for navigation because the direction is always constant. So the direction in this map projection isn't distorted. The shapes of things are not distorted. However, the area and the north and south poles are super messed up. So do you see how big Greenland and Antarctica are? It's because they've had to stretch it out so much. So the area of the north and south poles are way, way bigger than they are in real life. So like in real life, this is Greenland inside of Africa. But on that Mercator projection, it looks like Greenland is bigger than Africa. So although this map is good for navigation because the direction is the same across this map, the area, the surface area of the poles are way off. And you can see that right here. This is the actual size comparison, but this is what it looks like on the Mercator projection. Another projection is the Peters projection. The advantages of this one is that the area of the land masses are accurate. So the area of Africa is accurate here and the area of Greenland is, but you can tell that the shapes are inaccurate. So although the land area is like this, however many square feet this says it has, it's correct, but the shapes are way off. And especially towards the middle. You can see like the middle looks super stretched out and the poles look scrunched up. So this one is not good for navigation at all. But it does reposition the countries to their rightful size, but the area, but the shape is way off. This is the Robinson projection. You've probably seen this one a lot because this is a compromise of like all the other maps problems. There's no major distortions. There's just a little bit of everything. So it's not like the shape is super off or the size is super off or the distance. They're all a little bit off, but it's a good map to use generally because it's a good reference map, because there's no like giant distortions. But that is also the disadvantage, is that all aspects are slightly distorted. So the advantage is the disadvantage. So you wouldn't really use this to navigate, because the direction is going to be off, but it's good to use in classrooms, um, because it it kind of looks spherical, and the area and the shape is pretty close to normal. So these are some weirder projections. So the conic one that I mentioned earlier, so this is what the globe looks like projected onto a cone shape. And this one is called the Fuller projection. This one is actually the Earth projected onto like a 20-sided figure, but people like to look at this one to see how connected the globe actually is. You would not want to use this for navigation, obviously, but people just like to look at it as far as like migration patterns and stuff, because you can, like, the lines don't have to really cross water. You can see how people have moved throughout the Earth. So those are the types of map projections and the reasons maps are distorted. So make sure you answer the question underneath this video, and if you get it all right, you'll move on to the next topic. But if you don't, then you'll watch like a review video, and then you'll move on. So make sure you go and do that, and I'll see you at the next topic.